In this problem, we're asked to solve the following system by substitution. We're given the equation y equals negative 2x minus 10, and our second equation, negative 2x minus 6y equals 10. So these two equations make up our system of equations, and we're asked to solve it by substitution. Now, in the first equation, what you're going to see is that we have this equation already set up for us in point-slope form, which is y equals mx plus b. In the second equation, we have it set up in what's called standard form, which is ax plus by equals c. So we have two different formats here of equations. Now, we want to find out what the variable x would be equal to and what the variable y would be equal to. So I'm going to start off actually with this equation that's in point slope form. So we have our equation y equals negative 2x minus 10. Now, as I said previously, this is in what's called point slope form. We have our term with our y first, then we have our equals, then we have our term with our x and its coefficient being negative 2, and then we have this number here that's a constant term, negative 10. This is representing where this line would cross the y-axis if we were to graph it in the coordinate plane. So when we have an equation set up like this, where it's solved for a variable, y equals some algebraic term like negative 2x minus 10, this means that y and this algebraic term are equal to each other, but it also means that they are interchangeable. So I could replace a y in, say, the second equation with the algebraic expression here, negative 2x minus 10. And that's exactly what I'm going to do. So I'm going to take my second equation, negative 2x minus 6y equals 10. I'm going to take this y that I have in this particular equation, and I'm going to replace it with the algebraic equivalent or algebraic expression of that, which is negative 2x minus 10. So the start off this equation is going to be still negative 2x minus 6 times the algebraic expression that y is equal to, which is negative 2x minus 10 equals 10. Now, from here, what I'm going to do is I'm going to expand out this quantity of this negative 6 times negative 2x minus 10 by using the distributive property. And I'm going to do that by taking negative 6 times negative 2x and then taking negative 6 times negative 10. Everything before that in this equation, like the negative 2x, and everything after that part, this equal 10, is going to stay exactly the same as it is. So I'm going to say negative 2x. Then I'm going to say negative 6 times negative 2x. When I take and combine those two things, that's going to give me a positive 12x. When I take negative 6 times negative 10, that's going to give me a positive 60. And then that's going to be equal to 10. Now, from here, we're going to go through and kind of evaluate what we have in our equation here. So negative 2x, that's going to be a variable term. I'm going to label that as VT. 12x, that's also going to be a variable term. So I'm going to label it as VT. Positive 60, you'll notice there's no variable there, so that's going to be a constant term. Then we have our equals. Then we have 10, which is going to be a constant term as well. So in this particular equation, we have three terms on the left-hand side of the equals, two variable terms and one constant term. Then we have a constant term on the right-hand side of the equals. So what I need to do is I need to combine my like terms that I have on either side of my equals. So in this case, I'm going to combine the negative 2x with the positive 12x. So when I do that, that's going to give me a positive 10x. I still have that plus 60, and then that's going to be equal to 10. Now from here, we have a variable term with 10x and a constant term with 60 here on the left-hand side of the equals. Then we have another constant term with 10 here on the right. So now what I want to do is I want to get all my constant terms on one side and all my variable terms on the other side of the equal. So I have only one variable term here, this 10x. So I'm going to leave it right where it's at, and I'm going to get rid of this, this plus 60. Okay, so in order to get rid of this plus 60, I'm going to do an inverse operation. I'm going to subtract 60 from the left-hand side of the equals. And what I do on the left-hand side of the equals, I must also do on the right, according to the subtraction property of equality. So when I take a positive 60 and a negative 60 and I combine those two things are going to cancel each other out, and it's going to give me a 0. The only thing I'm going to have remaining on the left-hand side of that equals is going to be 10x. And that's going to be equal to 10 combined with a negative 60, which is going to give me negative 50. Now, from here, I have my variable term, 10x, on the left-hand side of the equals. I have my constant term, negative 50, on the right-hand side of the equals. From here, I'm now able to start solving. So I have 10x, which means 10 times the quantity x, and I want to separate that. I want to get this x by itself, which means I want to get rid of this 10. So since the 10 and x are being multiplied, I do the opposite of multiplication. I'm going to divide. And I'm going to divide this term by what I'm looking to get rid of, which in this case is going to be 10. Now, if I divide this side by 10, that means I have to divide this side by 10 also. So 10x divided by 10, that's going to give me x. And then negative 50 divided by 10, that's going to give me negative 5. So in this particular problem, my x should be equal to negative 5. Now, what I need to do is I need to figure out what y is going to be. Now, this x equals negative 5 means that x and negative 5 are interchangeable. So I could replace x in the first equation with negative 5 and then start solving for y, or I could use my second equation here and replace this x with negative 5 and then start solving for y in that case as well. It doesn't matter which equation you use, but there is a preferable choice here, and it's going to be the top one. The reason being is this top equation is already solved for y. So if I simply plug in x equals negative 5 right here and start using order of operations, I can easily solve for y. I'm going to have a few more steps to do that in that second equation. But it's possible you can use that if you like, but I am going to make it easy here, and I'm going to use the top one. So y equals negative 2x minus 10. Then what I'm going to do is I'm going to say let x equal negative 5, what I found it to be previously here. So I'm just going to go through this equation. I'm going to replace my x with negative 5. So that's going to give me y equals negative 2 times the quantity negative 5 minus 10. Okay, so I'm on this expression over here on the right, this numeric expression, I'm first going to have to take the negative 2 and the negative 5 and combine them according to order of operations. So when we take negative 2 times negative 5, that's going to give me a positive 10. And I'm going to be subtracting 10 because this doesn't change here. Now, when I take 10 minus 10, that's going to give me 0. So in this particular problem, my solution is going to be an XY ordered pair. And we're going to put our x first. So x should be negative 5. Made a little mistake there. X should be negative 5, comma, and then y should be 0. So in order for both of these equations to be true statements, I would need to replace each x in each equation with a negative 5, and I would need to replace each y with 0, and it would make both equations true statements.